Volume, parts 1, A, B, and C. Before you start this question, you need to make sure that you have your formula sheet, which was at the front of your package. So volume is the amount of space inside of a three-dimensional shape. So you might want to calculate volume if you wanted to know how much air goes inside a balloon or how much water you can put inside a glass. Anytime you're looking at the amount of space on the inside of a shape, we are talking about volume. So our question here says, calculate the volume of each of the following shapes. And it says round your final answers to 2 decimal places, which tells me that at least one of these is probably a decimal. So I have 3 different shapes. And if you look at your formula sheet, on the back side of your formula sheet are the 3-dimensional shapes. So there are 6 of them together. We have a cylinder. So that would be something like a can you would see in that shape. A sphere, that in the real world would be like a ball. A cone, so an ice cream cone, a party hat, a safety pylon. A square-based pyramid. So you might see containers sometimes in that shape. The pyramids in Egypt are in that shape. A rectangular prism, so a room, a box. There's lots of things in that shape. And then a triangular prism, so a really old school tent or a Toblerone bar would definitely look like that. So if I take a look at my very first shape here and I look at my formula sheet, I think this is a square-based pyramid. It's just upside down. So the first thing that I like to do is try to figure out what shape it is, and then I like to match the dimensions. And in order to do this, it really helps if you can get the same orientation as your picture. So I'm going to take the formula sheet and flip it upside down so that it's the same way as the picture that I have. So I notice that these sides here, they look kind of like Q's, but they're upside down. So they are B's. So this is the B, and this is a B. Inside the shape, making a 90-degree angle at the bottom, that is H, that's my height. And then there's this other side that's on the outside edge of the shape, so on the outside of that pyramid, and that would be our slant, but I don't have that, and I guess I could try to mark it on. So it's on the outside edge. That's our slant. That's what the S stands for. It stands for the slant height. So this is asking me to calculate the volume. Now the very first column of formulas are for surface area. So we want the second column, which are the ones for volume. So the surface areas or the volume of a square-based pyramid, it gives me 3 different formulas. It says volume is the area of the base, so that's the square on the bottom, times the height of the shape, and then divided by 3, which is the same as 1/3 b squared h, or b squared h divided by 3. So the b squared, that's length times width, that's how you calculate the bottom of that square, and then times the height, and then divided by 3. I like this very last formula, the b squared h divided by 3, but you're welcome to use whichever one you want. So I'm going to write my formula down to start. I'm going to say volume V equals b squared h divided by 3. So I already labeled in my diagram, my b is 10. So this is 10 squared, or 10 times 10, that's what it means to square something, times the height, which is 9. And this formula does not use the S, only the surface area formulas use the S. And then divide that by 3. So I'm actually just going to calculate that on my calculator. So 10 times 9 divided by 3. I don't think that's right. Let's try again. 10 times 10 times 9 divided by 3 gives me 300. So my volume is 300. Now, it is centimeters, and I multiplied 10 centimeters times 10 centimeters times 9 centimeters. So I ended up multiplying centimeters by itself 3 times, which means it's centimeters cubed because it's centimeters times centimeters times centimeters. So our final volume is 300 centimeters cubed. Our second shape is a sphere. So if I take a look at my formula sheet, there is only one dimension marked on this thing, and that is r for the radius. It does also have a diameter, which goes all the way across. But really, to do these formulas, you only need r. So if I mark that, radius goes from the center to the edge. So from the center to the edge, this is my radius. So the formula for the volume of a sphere is either 4/3 times pi times r to the power of 3, or r cubed, or volume equals 4 times pi times r to the power of 3, all divided by 3. I like this one better, so this is what I'm going to use. So I'm going to write down my formula and say volume is 4 pi r to the power of 3 divided by 3. Okay, I'm going to leave pi as pi for right now and use my calculator. My radius is 5. 5 cubed means 5 times 5 times 5. You multiply it by itself 3 times. That's what that means. And then that is divided by 3. So a lot of people will make a very common mistake, which is they forget to divide by 3. It happens. So I'm going to do 4 times. I'm going to use my pi button. If you do not have a pi button, 3.14159, please. And then times 5, times 5, times 5, and then divided by 3. And I got 523.59. I take a peek at the next number. That's an 8, which means it's going to push up the 9 to a 10. And then that 10 pushes that 5 up to a 6. So it becomes 523.60. And that is centimeters cubed. Now, because I rounded this one, I am going to put a dot over my equal sign to show that it is approximately 523.60. All right, our last one is a triangular prism. Now, you can tell the difference between a triangular prism and a square-based pyramid. A square-based pyramid meets at a single point on the top, whereas a triangular prism meets in a line at the top. This one, unfortunately, the diagram on the formula sheet is not great. So when I take a look at the formula sheet, you're going to notice that the picture on here does not look a whole lot like our picture. And we're just going to have to adjust. So what I like to do is look for the triangle. So I'm going to focus first on trying to find the triangle that's in the formula sheet and the triangle that's in my picture. So the triangle in my picture is there, and the triangle in my formula sheet, there is one up here, but the one that's labeled is down here on the bottom. So this one has the triangular prism standing straight up and down, whereas this one has it kind of on its side. The other thing I don't like is that they have switched up some letters. So I would normally consider this to be base times height times length, right? But they've switched what they consider H and what they consider L. So we're just going to deal with it. So this, where the base and the length meet, they meet at 90 degrees. So this is going to be my base, and then this is going to be my length. I did a cursive L because otherwise it's going to look like a 1. And then these two sides, you can't see them marked down here, but they are marked up here. This is A, and then this one is C. So I'm going to mark that this is A, and this is C. And then this, if I try to, well, there's no easy way. That's going to be my height. Now, I don't know what you learned in elementary school. I learned that this should be the height and this should be the length, but we're working with the formula sheet that the EQAO gives us. So that's what we're going to try to do. So I'm going to write down the formula. So the formula for the volume of a triangular prism, they have it in words. So the area of the base times height, they consider the base to be the triangle, and then times height. or 1/2 base times length times height, or volume equals base times length times height divided by 2. So I'm going to pick that last formula. That's the one that I like the best. Lowercase l's often look like 1s, so sometimes I will upgrade all of these to uppercase letters, or I'll draw it with a cursive L so that it doesn't look like a 1. Okay, so my base is 10, my length is 6, and my height is 8. And then that is all divided by 2. Okay, so 10 times 6 times 8 divided by 2 is 240. So my volume is 240 centimeters, and I multiplied 3 things together that were centimeters, so centimeters to the power of 3, or centimeters cubed. Check out the next video for help with the next question.